The next example we're going to do is going to be just like problem 4 in the additional exercises at the end of the chapter. Okay, so the one we're going to do here in the video says betadine solution is a 40% povidone-iodine solution. And it says to express the strength both as a fraction and as a ratio. Okay, so we don't have to worry about whether this is a solution with a liquid solute or a dry solute. Okay, so all we need to do is take this percentage, 40%, and write it as a fraction. Okay, so you may remember that any percentage, okay, when you write it as a fraction, okay, the number that's behind the percent symbol, okay, becomes the numerator of the fraction. Okay, so 40 goes in the numerator, and then 100 is the denominator. So for any percent, okay, the number that comes before the percentage goes in the numerator, okay, and the denominator is always equal to 100. All right, so once we have this fraction 40 over 100, we need to simplify it. So you can simplify it by hand, okay, or on your calculator, if your calculator can handle fractions. Okay, so let's go and put it in the calculator. Okay, 40 over 100, and press enter, so that it will give us the simplified fraction. So 40 over 100, okay, is the same thing as 2/5. Okay, so as a fraction, it's equal to 2/5. So as a ratio, right, it would simply be 2 to 5. Okay, so once you have the simplified fraction, okay, the first number in the ratio is the numerator, and then the second number in the ratio is the denominator. Okay, so the final answer is 2 to 5 as a ratio, and then as a fraction, 2/5. Okay, so the next problem we're going to do is going to be like problem number 9 in your homework. So I'm not going to go and do it because I've assigned it to you in the homework, but let me go and read the problem anyway. So a pharmaceutical company sells this drug in various strengths as listed in the chart. It says find the error in the strength column of the table by trying to verify that each of the 4 concentrations listed is equivalent to each of the corresponding strengths. So here's the table that I made up, and it looks just like the one you see in problem 9. And once again, the instructions say find the error in the strength column by trying to verify that each of the 4 concentrations listed, okay, is equivalent to each of the corresponding strengths. And you don't necessarily have to verify all of them, although you can. Okay, like for example, this matches up with this, right? This makes sense. So 3 milligrams per milliliter would be a 0.3% strength. Okay, likewise, 7.5 milligrams per milliliter would be a 0.75% strength. And then 20 milligrams per milliliter would be a 2% strength. So it looks like this is the strength. Okay, that's the error in the problem. So we're going to go and highlight it. Okay, and what it's asking us to do is to convert this concentration, okay, to a percentage, okay, to see if it matches the percentage given in the strength column. Okay, so we have 60 milligrams over milliliters. Okay, so the 60 is going to go in the numerator. So we'll put the 60 in the numerator there. Okay, delete the extra 60 here. All right, so 60 milligrams per milliliter, so that's understood to be 1 milliliter. Okay. All right, so when we convert the 60 milligrams into grams, okay, you multiply by, divide by 1,000, okay, or move the decimal point 3 places to the left, so 1, 2, 3, so this becomes 0.060 grams, okay, over 1 milliliter. Okay, so in other words, this is obviously a solution with a dry solute, okay, because the amount is given in milligrams. So converted into grams, that's 0.060 grams per 1 milliliter. Okay, so it's grams per milliliter. So once we have that, we multiply it by 100. We could express it as a percentage. Okay, so 0.060. Okay, divided by 1. Okay, divided by 1 has no effect, so then we multiply it by 100 to convert it into a percentage. Okay, we get 6%. Okay, so the actual strength, okay, of the solution, right, where there's 60 milligrams of the solute in 1 milliliter of solution, right, that's actually 6%, not 0.6. So we verified that the strength that is an error is this one here. Okay, so once again, I knew to convert the milligrams into grams because this very clearly tells me that this is a dry solute, right? 60 milligrams of dry solute in 1 milliliter of solution. So remember, anytime you deal with solutions with dry solutes, okay, the proper units are always grams over milliliters. Okay, so if the amount is given in grams, converted in, if the amount is given in milligrams, converted into grams. Likewise, if this is given in liters, converted into milliliters, and then simplify as necessary, and then to convert it into a percentage, multiply by 100. Okay, so this is very clearly the strength that is an error, and you can verify that the other concentrations, right, if you do a similar process, right, should be equal to the percentages you see here. Okay, let's go ahead and look at our next example. Okay, so we're going to look at number 9 on page 232. Okay, so let me go ahead and copy and paste it. Okay, and the question is, how many liters of a normal saline solution, all right, will contain 18 grams of NaCl? Okay, so if you're taking chemistry, you know that's the chemical symbol for sodium chloride, okay, which is essentially the composition of table salt, okay, sodium chloride, so NaCl, Na for sodium, Cl for chloride. Okay, so normal saline, okay, is a common solvent, okay, used in the medical field. Okay, so normal saline is always 0.9% NaCl. Okay, so in other words, this type of question is asking what volume of solution contains a given amount of solute. Okay, so in this problem, the given amount of solute is the 18 grams of NaCl. Okay, so we're going to convert the grams of solute into liters of solution. Okay, but before we do that, we need to convert the strength of the solution, 0.9% NaCl, okay, into a fraction, and to answer the question properly. So 0.9% NaCl. Okay, so since NaCl is a dry solute, okay, it comes in solid form, it's not liquid. Okay, we're going to express this as 0.9 grams. Okay, so again, it's given as a percentage. So 0.9 goes in the numerator in the units of grams. Okay, and remember, a percentage, when expressed as a fraction, has a denominator of 100. Okay, so we're going to put 100 milliliters in the denominator. Okay, so once again, NaCl is solid. Okay, just like your table salt is solid. Okay, so this is expressed in grams over milliliters. Okay, but because this is a percentage, the 0.9 goes in the numerator, and then 100 the 100 milliliters in the denominator. Okay, so this is our fraction. Okay, which is the strength of our normal saline solution. Okay, so using the dimensional analysis approach, okay, we're going to start with the 18 grams. All right, And because I want to know the number of milliliters of solution, okay, I want to cancel out the units of grams. So when I multiply by the fraction, right, and setting up this fraction, right, what goes where? So in this strength that is expressed as a fraction, right, does the 0.9 go on top or on the bottom? Okay, so since I want to cancel out the units of grams, okay, the 0.9 grams is going to go in the denominator. Okay, and then the units I want, which is milliliters of solution, are going in the numerator. Okay, so in the dimensional analysis approach, okay, the units of grams are canceled. And when we put this in our calculator, right, we're going to take the 18, multiply it by 100, all right, and then divide by the number in the denominator, and that should give us our answer. Okay, so we're going to get 2,000 milliliters, okay, which is equivalent to 2 liters of solution. Okay, so 2 liters of the normal saline will contain 18 grams of our solute, sodium chloride, or in other words, 2,000 milliliters will contain 18 grams of the solute. Okay, so the problem does say, though, right, how many liters? Okay, so 2 liters of the normal saline solution will contain our 18 grams of sodium chloride. Okay, so if this approach seemed a little confusing, there is another way to approach the problem. Okay, so if we go back to the basic formula that we discussed in the previous video, right, for determining the strength of a solution, right, strength is the amount of solute divided by the solution, right, the amount of solution. Okay, what we can do instead to answer this question, okay, is to set up a proportion. Okay, so a proportion is where two fractions are equal to each other. Okay, all right, so on one side, number proportion, okay, we get the concentration or the strength. Okay, so 0.9% is 0.9 grams over 100 milliliters. Okay, for the reasons I explained earlier. Right, when you convert a percentage to a fraction, okay, the number that comes before the percent symbol goes in the numerator, and then you have 100 in the denominator. Okay, but let's include the units there. So the volume of solution is in milliliters, 100 milliliters, and then the amount of solute, 0.9, is in grams. Okay, so that's one side of our proportion. Okay, and then on the other side, okay, we're given the amount. The given amount is 18. Okay, that's the given amount of solute. Okay, so that's going to go on top, okay, of the other fraction. Okay, we're looking for the unknown amount of solution. Okay, so now that we set up this proportion, right, we're looking for the unknown amount of solution. Right, so when you solve any proportion, you cross multiply. Okay, so we have question mark milliliters, okay, multiplied by 0.9 grams. All right, so cross multiply is equal to 100 milliliters, okay, multiplied by 18 grams. Okay, so in just a moment we're going to divide by the 0.9. Okay, but when we do 100 times 18, it should be pretty obvious that that's 1800. Right, just take 18 and tack on a couple of zeros. Okay, so we get 1800 milliliters times grams. Okay, you don't need to worry about the units too much. Okay, so to solve for the unknown amount of solution, right, in the milliliters, all right, we're going to divide both sides by 0.9 grams. Okay, so when I divide by 0.9 grams on the left-hand side, okay, I'm left with question mark milliliters, right, the unknown number of milliliters. Okay, so I'm going to take 1800 milliliters times grams, and then divide by 0.9 grams. Okay, so in the process, grams are eliminated, and we're left with milliliters. Okay, so I do 1800 divided by 0.9, and we end up with the answer of 2,000 milliliters, which is equal to 2 liters. And that's another way you can approach the problem.